Okay, here we are ready to go on the calculator part of the problem of the AP 2018 number 2. So the first thing they did was they added a calculator page and a graph page. And the original equation gave me a velocity equation that was equal to 10 sine 0.4 t squared over t squared minus t plus 3. I graphed that equation, but you'll notice I had to use x to graph it. And the very first thing it asked me to find in part A, and you have this in your notes, is it asked me to find the acceleration at time t equals 3. Well, acceleration is the derivative of velocity. So on the graph page, there's two ways to do it. I'm going to go menu, calculus. I'm going to go derivative at a point. It tells you what time I want the slope to be, or the derivative to be at for a prime. The variable is x. The value is they want the acceleration at 3. And I'll send you a picture of the paper with the information filled in when it's done. And the function, I've put it in the calculator, is why we use x instead of t. I'm going to go var f1 of x. So the acceleration at time 3, which is the derivative of the equation we have, is negative 2.1182. And we always round to the thousandths place. So we negative 2.118. No units of measure because it didn't ask me. As a matter of fact, in the question, it has no units of measure. So we are going to not try to put those things in there. So I filled that first piece in. The next thing it says is to find the position at time t equals 3, which is going to be equal to, we already wrote this on out, where it was at the start, because position at the start, which is negative 5. I'm going to type it in myself, negative 5. Plus, to find how far it went, it's going to be an integral, menu, calculus, integral, from 0 to 3. I already have the function in there. Let's go var f1 of x dx. That's why we changed from x to t, so we can put it in the calculator. We'll hit enter, and I've got negative 1.7602, which on my document is going to be negative 1.760. That's to the thousandths place. I'm circling both of those. We have those notes already in there. It says next, it says evaluate the integral from 3.03.5 of v of t and the integral from 0.3.5 of the absolute value of v of t. I'm just going to start it here, calculus, integral 0 to 3.5. V of t is stored in f1, and that's why it's so much easier to store it in the calculator, so you don't have to retype it. Is that, and then I'm going to grab this. I think I can put it in there. Let's delete this out. Mustache man, absolute value. Var f1 of x. You didn't have to delete everything I did. It just makes it easier when we're working out the problems. And I got two numbers. And I got 2.8439, which is equal to 2.844. And for the next one, I got 3.7371, which is 3.737. And you can see on here the total distance walked, the total distance traveled is more than the displacement, which makes sense. And I've already described it in the problem before. This is this is displacement, this is where you are compared to where you started. This is how far you've walked. Absolute value adds up all your distance, whether it's positive or negative. Okay, now the last part asks me to see when the two velocities of the two functions are the same. So I've already graphed the first one, which is here. Now I'm going to graph the velocity of the second particle. And the mistake that a lot of people make is they put the original function in, which was t squared minus t, which is the displacement. I need to put in 2x minus 1, which is the derivative of that. I know I changed the variables. I did that on purpose. I'm going to hit enter. And those things are going to intersect at some point. It looks like right here. I'm going to find where they're the same. Menu, analyze graph, intersection, go before it. after it. Okay, and these two things intersected at time t equals 1.5075, which if I were to reduce it down would be t equals 1.571. And on the problem it says, at what time are they moving the same? You might even type in, you put them in the calculator and found where they met. We have that value right there. I feel like this one has a lot of easier parts to get some points on. We've worked it on out. I'm going to send you a picture of the, let's see if I can send it right here. Hold on. You should see the screen. Let's make it full size. So I filled in the numbers that we found for these values right here. And I will send those out to you. Fill those into your review book so we have them there ready to go. We'll have one more of these type of problems on Thursday. So we have all our displacement velocity acceleration problems down and ready to go. Okay, folks, see you later. Bye.